Hello and welcome to everybody. Thank you all for coming in tonight. I just want to, I want to start us off by letting you know a little bit about Delaware-Otsego Audubon Society. I will often refer to the organization as DOAS, and I remember a couple of weeks ago somebody said, "What does that mean?" So I figure I'll start off by just saying that DOAS, when we refer to it, means Delaware-Otsego Audubon Society. Our mission is to protect our natural environment and connect people with nature to benefit birds and other wildlife through conservation, education, research, and advocacy. One quick announcement on the DOAS side tonight is that we're holding an optics raffle, which is currently taking place. We have 250 tickets available, $10 per ticket, and there's a chance to win some great binoculars. We have Monarch 7 binoculars with shoulder harness as first prize, Monarch 5 binoculars with shoulder harness as a second prize, and then a $50 gift card to Wild Birds Unlimited in Johnston City. We've got about 175 tickets left for sale, and the drawing will take place at our April 16th photo share program. You can find full details about that at our website at www.doas.us. So thank you for joining us for this evening's program, The Climate Our Evolution with Dr. Kevin Schultz. If you have questions during the presentation, please use the question and answer section in the Zoom control panel. So somewhere on there, you should see a Q&A button, and you can open that and take a look at questions there. You can also use the chat box. We'll be monitoring that, but it's harder for us to track what's been answered there. So we're trying to drive people to use the Q&A section for questions and answers. Our moderators for this evening are Becky Gretton, who is a co-president for the organization, and Charlie Scheim, who is our treasurer. I'm Susan O'Handley. I'm a co-president as well. I forgot to mention that at the beginning. Tonight's program is part of our Climate Action Initiative for this year, and I would like to ask everyone here at some time over the next few weeks, look at your household carbon emissions and use our new tracker app through our website. So doas.us carbon tracker. And this is a tool that will help you measure where your household is currently. So it'll collect some baseline data on what your household carbon emissions are. And then it will help guide you towards things you can do to bring those emissions down with a goal of net zero by 2040. So we've got a lot of work to do in 20 years' time. So this is a long range plan, but with a need to really act fairly quickly, kind of in the long term. Please contact me if you need any help or guidance with that. I do have office hours set aside on Tuesdays and Thursdays. So if you need help or you're just not sure where to start or how that works, please reach out. If you are interested in climate change, which I'm assuming that everyone here tonight is, and taking action, we are growing an area network, and we're looking for people who want to get involved. I will email everybody after this evening's program later this week with an invitation to join us on our Climate Action Network. And this is an area where we can continue our discussions and learn from each other. We can share resources and information and provide guidance on some climate-related projects. Dr. Schultz will be in the network. He is in the network currently. So if you have questions after tonight and you want to follow up directly, we can have those conversations there in that platform. We have 2 more programs coming up in this series just over the next few weeks. Pre-registration is required for each of them. Information is on our website under the events or calendar section. Next week, on Wednesday, March 3rd, 7 p.m., we're doing the ins and outs of electric vehicles, an owner's perspective, and that's with question and answer. It'll be a little bit more informal with Tom and Celeste Tice. Wednesday, March 9th at 7 p.m., green heating and cooling for homes and businesses with Bennett Sandler from Heat Smart Mohawk Valley. So now I'd like to introduce our presenter for this evening, Dr. Kevin Schultz. Kevin is an associate professor and chair of the physics department at Hartwick College, as well as the chair of the City of Oneonta's Environmental Board. He moved to the Oneonta area with his family in the fall 2012. For the past several years, he has been engaged with the community and his college to work for a more sustainable Oneonta. He has taught courses on energy and climate, math and science of social justice, and is developing a new course on sustainable agriculture. Welcome, Kevin, and please feel free to add anything that I might have missed.
No, I think you got it all, at least all the relevant stuff. So it's a pleasure. Thank you for inviting me. This was going to be a slightly different talk way back in April of 2020, a different forum at least, but I'm glad that we're finally getting back to this. As I was looking at some of my older presentations, I found that it is coming up on the 2nd year anniversary of my last talk to DOAS. I was in the middle of March sometime in the basement of the Methodist Church, so it's nice to be back talking to you all. I also I see my mom is in here, so happy birthday, Mom. Thanks for coming. Appreciate it. And for any of you guys that are in there that are here because I guilted you, thank you. So I'm going to do my best to keep this thing about an hour. I've yet to succeed, but we'll do a lot. I think it's starting to morph as more and more people are starting to accept that the climate is changing, and we're getting a better. People are getting more and more involved in understanding how the science is. I'll probably move a little bit faster through that part. But there's a couple things that I do want to share. So I'm going to go ahead and share my screen. This presentation is a Google Doc, so you can, I will provide a link for it. It should be showing up in the chat at some point tonight. And it'll also be on that Climate Network site in one way or another. And I will also have a thing of resources, a list of just web pages that I found useful over the years. And so while we're thinking about this, what I've got here is a video from NASA looking at temperature anomalies. So just stop right here. Going back from 1880, and every 5 years it updates. So you can watch that over here. So we're now right in the World War I era right over there. And what we mean by anomaly is, so basically what they've done is they've taken average global temperatures over probably about a 50-year time period. I can't remember exactly from this video. It's something like 1900 probably to 1960. And what we're looking at are deviations from that. Okay, so the scale is over here, but basically blue means you're below the that kind of 50-60 year average from the mid part of the from the beginning to the middle of the 20th century. Anything yellow and red were well above. So like I said, right now we're in 1914 to 1918. We're starting to see a few hot spots. So we're seeing a little, oops. Gotta love it. All right, so I won't click on anything else. So here we are. We're now back up to our 1900s, beginning of that. And really, it's, sometimes you see something a bit different. And now we're kind of right at the average. And now we're in post-World War II. You see some warming spots. But again, since we're right in the middle of our average that we were taking, we don't see a whole lot above or below during these decades. But now we're getting into the 1980s, right? And now we're into 1990s, early 2000s, and then up to about 2017. So that's the last slide here. I want to point out that one of the signatures of climate change due to greenhouse gases is that the prediction is that you would start to see warmer temperature anomalies in the Arctic, and also to some lesser degree in the Antarctic regions. And that's exactly what we're seeing here. As we're losing the moderating effects of snow and ice in the polar regions, but they're nice and bright, right? They give you snow blindness. They also get rid of a lot of light, visible light from the sun and reflect it up into space. And as we lose some of that, we're more effectively trapping the sun's energy. And so we're warming up. So that's one of the key signatures of what we would expect to see. So anyway, I had a different title a number of years ago. And then about last year, I gave a presentation at the Bushel Art Collective. For those of you who are in this area, it is a wonderful new space that they've got. And a colleague of mine at Hartwick, Rich Barlow, had an exhibition there. And so what's behind here is some of his chalk drawings. If you've never seen, he gives, he has art exhibitions all throughout the country, but also he has a bunch in this area of New York. So if you ever see his name pop up, go and see his artwork. What you're seeing on the back there is a chalk drawing. He basically just paints over a wall and then projects the picture that he wants to present. And then he just takes the side of his chalk and makes that picture. This picture is probably done rather recently after he had done it because there are no obvious smudge marks. It's always fun to go to his presentations because you see a line of chalk at the bottom, the chalk dust, and then the occasional fingerprint, as people say, and then looking, oh yeah, it's really chalk. But anyway, as I was getting ready for this this presentation, and he had, it was a great talk that I was able to give because it was in the last one before the pandemic, but it was also in the midst of some of his work, which we'll see in a little bit. And as I was getting ready to give that talk, I came across sort of this this poem by Assata Shakur, and I really, really like it. And I like this. This is where I got the idea of the revolution evolution. And you know, as you can look at, you probably already read this part. It's some more of his artwork. We need a revolution and evolution of our minds. We need a revolution, evolution of our heart. We need a revolution, evolution of the spirit. And I find these words to be very inspiring and helpful as we go and I start to think about what we need to do. We need to be able to combat climate change. And maybe this sounds weird coming from a physicist. I don't know, hopefully not. If it does, and we're probably not doing our jobs well, but we need weapons of mass love. I love that line. We need to love our earth. We need to love the people that are on it and the animals that are on it. And we need to love ourselves to be able to actually, it's only with that deep and abiding love for the world that we're going to be able to have the energy and the willpower to move forward. Oops, yep. It means, you know, respecting and learning from our children. It means protecting the people, the plants, the animals, and it means saving this planet. And I like this idea of revolution, evolution as well, because what we need to, what I've been coming in as I work more and more on this, and I work more and more within the city, and I do all sorts of different kinds of social justice projects and environmental justice projects and sustainability projects. What I find is that we are making progress, and in order to get to where we need to go, we need both the things that we need to do turn out to be both an evolution of what we're doing, but also once we're done with that, will result in kind of a revolution of how we think. And so I really the evocation of both something so sudden that you think about as revolution, while at the same time that slow unraveling of evolution just seems to be the phrase that captures what needs to be done. And so here we are. So things, if you're here, chances are I don't need to convince you about anything. And so this is last month's weather, rather, January 2020 in the contiguous United States, or CONUS. And it was the 9th warmest January on record. It was the 3rd driest January. And the Great Lakes are on target to only be at about 30%, oh, that should be iced over, sorry, iced over 30% of ice compared to an average of 53%. Right, so we are seeing changes. This is just one example of the kinds of things we change. And again, there's links down here that I got this national climate chart from, and the NOAA, the National Oceanographic and Atmospheric, I don't remember what the other A is. They put these things out every month, and then they do another thing over the whole year as a kind of a climate snapshot over that. Again, climate change is real. Again, I don't think that if you are here that I'm going to have to do a whole lot of convincing, but New York State is warming about 0.2 degrees Fahrenheit per decade, and the United States is warming by about 0.16 degrees Fahrenheit per decade. Notice that discrepancy, right? The United States as a whole seems to be warming slower than New York. But go back again to that YouTube video I showed, and I was talking about at the further up you are, the higher north you are, closer to the Arctic, or the further south, closer to the Antarctic. Those are the places that you're going to see warming happen faster, right? And so we go and you look state by state, you'll see that in general, the northern states are warming at a faster rate than the southern states, and so that's why New York's is going faster than the United States as a whole. And again, this website over here, if you ever want to get a chance to play with this is all wonderful data. All you do is you click on the state that you want to look at. You click on whether or not you want to look at January or March or a season, or the way that I have it here, an entire year. And you can plot little trend lines and means and stuff like that. And so here is the average from 1901 to 2000. So if you average up all the temperatures during that period in New York, the average yearly temperature was 52 degrees Fahrenheit. I'm sorry, this is the United States up here. I apologize, I got them switched around. So this is United States, here's New York. In New York, it was 44.5 degrees, that makes more sense. And these are the average temperatures over the years. And so you see that there is this variation. We expect variation. But back over here, we see that, it was kind of bouncing around the mean. You had just as many above average years as below average years. But then starting around the 1980s, we see this start to just go way up over along here. And we just see that, yeah, we might have a cooler averages, but we are well above what is happening doing that. And so again, the same thing here for New York. If any questions you have a question, just stop me somehow. Somebody will let me know to stop talking. Otherwise, I won't. But I am happy to stop and answer questions at any point. So here are kind of three phrases that various people we've heard, I'm sure, in different contexts. In the upper left, right, we have Scott Pruitt, the National Review, in May 2016, saying, so this is one phrase that you might hear: scientists continue to disagree about the degree and extent of global warming and its connection to the actions of mankind. You have Jonathan Franzen in September 2019, going in the complete other direction. It probably makes no difference how badly we overshoot 2 degrees. Once the point of no return is passed, the world would become self-transforming. We hear both of those quite a bit in the climate world, and I would argue that both of them are wrong. Clearly, the Scott Pruitt is wrong for different reasons from Jonathan Franzen. And as much as I admire Bernie, it is also not quite right to say that Hurricane Dorian, that we can pinpoint a particular aspect of the weather on climate. And I know that that's not where he was going with that he was going to say that there is a likelihood of increased hurricanes as the climate changes. And we'll talk a little bit about what we know and what we don't know. I try to stay away from any kinds of extremes of things that we don't know for sure, because this is a tough enough problem, right? We have one hand, we have people still less so saying, oh, global warming is just not a thing. And lately we've had this complete opposite response, like Jonathan Franzen saying, everything is doomed, right? If we just, no matter how bad we overshoot 2 degrees, once that point of return, no return is passed, it's all over, right? And if we don't get everything done by 2030, we're, it's going to hell in a handbasket even faster than we already are, right? That's not true either, and it's not helpful, right? When I start to hear what I like to call the climate apocalypse people, it just kind of gets defeating. And I don't want anybody to walk away thinking, oh, Kevin is saying that, everything is fine and we don't need to worry about it or whatever. I mean, we have some real issues. People are being hurt. People are dying. Animals and plants are dying right now because of the state of the climate right now that we put it in. And it will continue to, if we continue to do things and not mitigate and not try to adapt, a lot more people are going to get hurt and die as well. I'm not trying to say anything like that, but sometimes when we start talking about these things, it goes so far overboard that it becomes self-defeating. I have seen in, respectable kind of newspapers and magazines, things like, oh, people just get so hot they'll catch on fire or something like that. I'm just like, no, that's not how this works, right? And so one of the things that I want to share with you guys today is the science of global warming. I want to share with you some of the things that we know and we don't know and how well we know it, because that's one of the hallmarks of being a scientist, is that and this is what makes scientists so annoying to listen to. It drives my wife absolutely insane. Can't you just say something straight without any qualifications? Well, yes, but the problem is that scientists, we always are trying, good scientists at least, are trying to say, here's what we know, here's how well we know it, right? We know this really, really well. We're really confident in this thing. We're pretty confident this is happening. We wouldn't be surprised if this would happen. And, I don't know, maybe over here, maybe it'll happen, maybe don't. We just don't have enough information yet. Right. And so that's some of the things that I want to talk about. So getting to that first thing about Pruitt, man, that's just, so turns out it's probably even more right now. 97% of scientists agree that human-caused climate change is real. And it turns out the more climate expertise a scientist has, the more likely they are to come to this conclusion. So if you look and you say, oh, what about those 3% of scientists? Well, I'll be honest, they tend to be like computer engineers. They tend to be maybe nuclear physicists or something like that. They tend to be far away from the kind of climate world. When you start to look at the scientists, the scientists that are biologists, chemists, and atmospheric scientists, and physicists, and things like that, the closer they are, their background is to the particulars of climate change, the more likely they are to be saying that. One of the other arguments, and this is why I have this adorable little jigsaw puzzle here, is that, and it's getting less than this, but for a long time, people are like, well, the science is still not out yet. Right? It's the same thing they said about cigarettes, right? We just don't know enough. And at this point, if I were to ask you, and if, I would probably, I say, well, what is this jigsaw puzzle a picture of? Most of you, I would hope, would say it's some kittens playing with some yarn and it's pretty darn adorable. I would then say, well, no, actually, we don't know that for sure. It could be some kittens, but, it could be like some dragons about ready to attack them. We just don't know, right? Because there's these 4 pieces right over here. Who knows, right? Anything can happen in those 4 pieces. And it's ridiculous, right? You question my sanity. It's the same sort of thing that we've got right now. At this point, we have understood the science of greenhouse gases and climate change for over it.
Oh, Kevin, we seem to have lost your feed. Some technical difficulties here. We may need you to relog, maybe? Oh, wait a minute. There we go.
Am I back?
You are back, yes.
Okay. My internet connection is unstable, apparently. Apparently so.
Okay.
All
I'm
right,
glad it
so
was
we'll,
just your tech end and not our tech end.
yeah, no, if it goes out on my side, if I start to break up, it's on me, the way that Zoom works.
Okay.
Okay, so my thing here, so, but yeah, just get that out to me and stop me. I appreciate that. It's just Zoom, right? So right, so we understand this physics going back quite some time. Our house was the first one to postulate that CO2, carbon dioxide, was likely to be a greenhouse gas. And this was back in the 1910 or something like that. And then over the ensuing decades, by the late 1930s, 1938, there was work done that really seemed to indicate the amount of carbon dioxide that was being historically emitted could be correlated with the temperature change that they were already seeing in 1938. By 1950s, work done and known by the Fossil Fuel Consortium, the American Petroleum Institute, it was very clear that the oceans were not as big of a mitigating effect as they had thought. And so really by the early 1960s, it was pretty clear what was going on. And so what we've been doing since the 1960s is we've been filling in those last little puzzle pieces, right? We've been spending a lot of time trying to get our predictions, our modeling done so that we can understand what the future might hold for us under different scenarios. But we've understood. The fossil fuel companies did a bunch of research into this all up and through the early 80s, and it's just been known. There is no doubt about it. The climate is changing. CO2 has been put into the atmosphere at record rates, and it is a direct correlation to what we're doing. It's as simple as that. And the way we know it, again, is we have all sorts of different ways of getting to that information. So kind of what are the things that we do know with high confidence? So this comes from the IPCC. They're the ones that do these big climate reports every 5 years. So this is AR5. There's another one coming out next year. So this one's about 5 years old. So things will be updated, but unfortunately they don't get updated fast enough for my talks. So scientists will say with high confidence that more than half of the observed increase in global average surface temperature from the latter part of 20th century till 2010 is caused by anthropogenic caused increases in greenhouse gas concentration. There's just high confidence. We know this thing, there's no doubt about it. We know that these anthropogenic forcings, basically putting carbon dioxide into the atmosphere, have made substantial contributions to increases in global upper ocean heat content. So the first 700 meters observed since the 1970s. We have incredibly high confidence that it is greenhouse gases that are causing that. Still high confidence, but not like, knock it out of the park with no problem kind of confidence. It is very likely the number of cold days and nights has decreased and the number of warm days and nights has increased on a global scale. Still very, very high confidence on that. We have very high confidence that climate-related extremes reveal significant vulnerability and exposure of our ecosystems and many human systems to current climate variability, right? So we know that we have a lot of work to do to be able to adapt, right? There's the mitigation aspect, which is to try to mitigate our greenhouse gas emissions, to lower that and come to stop it. And then there is our adaptations to the climate change that has already happened and will continue to happen. What we don't have really great confidence on are frequency and magnitude of floods on a global scale. We don't really know exactly how cyclone and hurricane activity is attached to global climate change. We just don't have enough data. We're pretty sure it makes sense. I mean, it makes sense. More energy content in the ocean should mean stronger hurricanes. We're starting to see more hurricanes. It seems like, but again, our data doesn't go back far enough and so on. So we're still working on that. So again, I wouldn't be surprised if that were true. And I certainly wouldn't make a big deal out of combating that. But I just want to kind of point out, here are the things that we know with high confidence, and here are things, wouldn't be surprised by. We just don't know things about droughts and how that is associating with climate change. There have been historical times of droughts and other things, and it would make sense. But whether or not what we're seeing now is directly attributable to climate change, we're still not entirely that confident about. The thing that I want to point out that gets to that last thing, sort of about Franzen's thing, is that these worst case scenarios do not need to happen. We have options, we have solutions, right? And each passing year, our options are reduced. So if we had started aggressively combating climate change in New York State by 2010, then in 10 years from now, we would have saved about $16 billion as a state, right? There is so much evidence, and, obviously a time for another talk. But for instance, the New York State is one of 13 states that take part in a regional greenhouse gas initiative, as a kind of carbon trading program for the East Coast and Middle and the Atlantic state, the Northeast, New England states. And those states have had, they've been doing this for about a decade now. They've had incredible drop-offs in carbon emissions, while at the same time, relative to states that aren't in it, their overall economies have grown faster, right? So it is clear that there is that we can be making these options, we can be making these choices, and it's not only is it the right thing to do for the planet, but it's also the economically correct thing to do. All right. So at this point, probably most of us already know the difference between climate and weather, but just in case you want to have a good thing about this. So I took this from the Cosmos reboot, Neil deGrasse Tyson, from a number of years ago. So walking the dog. And so I live over here in Oneonta, and here's Wilbur Park, for those of you who know it, and the creek goes right along here. And I'll take my dog Max here. Before he was shaven, he had recent surgery, so that is now a big blank spot with stitches, but he's doing fine. We go for a walk, right? And we'll follow this little path along the creek. And of course, because I am a conscientious dog owner, Max is on a leash. And so this black line here is my path. And then the purple line here is Max's path as he smells a stray squirrel or some other thing of interest. And so he zooms back and forth, back and forth. But because he's leashed, he has to follow my path, right? So his back and forth here is like the weather. It's going changing back and forth, but it's always constrained by the average that is me, right? And so the weather, so maybe you've heard this phrase, I love it. This is the best way to understand what is really happening. Climate is what we expect. Weather is what we get. And for years, I've been attributing this to Mark Twain, because that's where I thought I heard it from. And whenever I give one of these talks and I put something new into it, I always have to do a background check, because I try to make sure that there is nothing in here that I know to be wrong. This is how I learned that ostriches do not actually bury their heads in the sand, which I'm really glad I figured out before my last talk to you guys, because that would have been embarrassing. So instead, it's probably not actually attributed, it's usually attributed to me, but he probably never saw it. If you go to this website over here, quoteinvestigator.com, they answer this question, and there's pages and pages of documentation where it most likely came from. So there you go. Okay, so greenhouse gases and
quick
and
pause,
light.
Kevin. I think Charlie has a question. Charlie, go ahead and unmute.
Sure.
Kevin, just to return to your high, medium, and low confidence events, one thing you didn't mention is anything like this extreme winter weather that happens, say, in Texas, and people talk about polar vortex. Can you talk at all about, is that connected to climate change? High, medium, low probability, et cetera?
Yeah, I don't have those that confidence at my fingertips. I should probably, that's a good question. If you want to put that into the, if you want to re-ask that in your climate portal, I'd be happy to look that up. From my understanding is that this is consistent with what we would expect from a warmer Arctic. Typically, the jet stream is a very, very fast moving stream of air in the upper atmosphere, and it circles the Arctic. And what that does is it basically keeps that cold air in the Arctic up there, right? And when you start to have warmer weather in the Arctic, then that temperature difference between kind of the Arctic regions and that subarctic regions is not as big of a difference, and that seems to weaken that jet stream. And so that cold air being so dense can start to push that jet stream down, and then all that cold air kind of slides down and hits us. So usually then what happens is you get a bunch of people say, well, what about that global warming? If you look on the other side of the globe, usually what happens during one of these kinds of events is that some other part in the northern hemisphere is much warmer than usual, right? Because that cold air is coming down and it's going to get replaced with warmer air from somewhere else. So I don't have a high medium confidence thing on that, but from what I've been able to see over the recent couple of years where we've been experiencing that does seem to be something that has got some, I would imagine would be a high confidence, but I will definitely look that up. That is a good, I'll have to see if it's in that report. Yep, no problem. So I might not always be able to answer a question, but I'll look it up later on. So, all right. So light is basically a vibrating electric and magnetic field. And how fast it vibrates up and down basically tells you the color, right? And so visible light is just this side region. The wavelength of light in the visible region is about the size of a protozoa. That's why we can't see anything very much smaller than that with our microscopes in visible light. Infrared light has wavelengths that are about the size of a needlepoint. Microwaves are longer, and they're about the size of a butterfly or a human, and radio waves are, building size. And these are less energetic light. As you go this way, you have ultraviolet light. So that's just to the left of the blue light, and it's got a wavelength of the size of molecules. X-rays have a wavelength about the size of atoms. Gamma rays have the size of the nucleus of an atom. And then up here, we have kind of a rough thing about do these wavelengths get through our atmosphere? So ultraviolet, X-ray, gamma rays, thank goodness they don't, because we would be having a lot bigger problems than anything else. Visible light obviously is a big yes. And then there's kind of a little gray zone. Microwaves don't really make it through. Radio waves make it out. And right here in this infrared light area, yeah, some of it does, some of it doesn't. And that's going to be the key thing. So if you've ever gone to a place that has a forge, or you've used the phrase white hot or anything like that, you know exactly what I'm going to be talking about here, even if you don't know it. The hotter something is, the more light it emits. And not only does it emit more light, it emits light of different colors. So something as hot as the surface of the Earth's, of our sun, puts out a tremendous amount of energy in the form of all sorts of wavelengths of light, but primarily in the visible light, which is why our eyes evolved to be invisible. Something cooler down over here is going to be in the infrared, and something the size, like the Earth's temperature is going to be way, way, way down over here in the far infrared. Okay, so that's the key thing for understanding greenhouse gases and the greenhouse effect. The sun primarily puts out light in the form of visible light. That visible light makes it through our atmosphere undisturbed. It goes to heat up the Earth. The Earth is now warmer, and it is going to emit its own energy light in the form of light, but it's so much colder, it's going to emit it in the form of infrared light, and that's going to go off into space. Okay, so visible light and some other stuff coming down from the sun warms up the Earth. the Earth re-emits that light as infrared, because if it didn't get rid of that energy, eventually we'd be absorbing all this energy from the sun, and after a few million years we'd be melted or something like that, right? So we got to get rid of that heat that we are absorbing from the sun, and we do that by the Earth does that by re-emitting that energy, not in the form of visible light, in the form of heat or infrared. But as we saw, not everything transmits light the same way. So here's a thermal camera picture. It is both a picture of, it's a camera that I got that both takes in visible light, so that's why you can see my one daughter over here. And it also takes in thermal light. And since both of my daughters are active and warm-blooded, they emit lots and lots of infrared light. But if you notice, my older daughter over here, who is under a black plastic bag, just for a moment, she was able to breathe, don't worry about it. We could, if it was a little bit bigger pressure, you would be able to see her underneath here. That black plastic bag is transparent to infrared light, even though it is opaque to visible light. So I couldn't visibly see her underneath there, but my thermal camera tells me. My other daughter here should also be glowing quite brightly in the infrared, but she is behind our screen door. And glass is a very, very good blocker of infrared light. Right? So some things are very good, but it passes visible light through. So in this case, glass is kind of like our atmosphere. It passes visible light through, but it doesn't pass infrared as well because of the greenhouse gases. If our atmosphere was only made up of oxygen and nitrogen, then the infrared light would be able to escape off into space with no problem. But the presence of carbon dioxide and methane and nitrous oxide and water all contribute to the greenhouse gas effect. Because what happens is that light, that infrared light that's coming up off the surface of the Earth, it interacts with, say, carbon dioxide. Visible light doesn't, it just passes right through it. But that infrared light, carbon dioxide is kind of like a three atoms in a row. There's a carbon in the middle and two oxygens on the side, and they can start to vibrate, right? Or they can start to do other kinds of motion like that. And those motions are activated at low energies. And so when that infrared light comes up, it all of a sudden starts to get the carbon dioxide molecule to vibrate. And then eventually that carbon dioxide molecule will get rid of that energy and re-emit that infrared light. And sometimes it'll re-emit that light back upwards into space, but sometimes it re-emits it backwards, back down to the Earth, and warms the Earth up a little bit, right? So if there were no greenhouse gases, just oxygen and nitrogen in our atmosphere, the global worldwide temperature would be about -1 degree Fahrenheit. By adding bits of carbon dioxide at the order of a few hundred parts per million, so if you count up all your molecules, every million of them, you'd have about 140 carbon dioxide atoms. The global mean temperature rose to about something like 47 degrees, 50 degrees Fahrenheit, averaged around the world over all year. So without some of these natural sources of carbon dioxide and methane and things like that, the Earth would be a lot colder. What we're doing is we're just putting more and more up there. So here's another little picture of this. This blue line here would be the spectrum, the colors, infrared light that Earth would be trying to get rid of. This is the light that the Earth.
We lost you again, Kevin. So we'll just pause for a second, wait for your internet to catch up.
And it's not. Hello. You there?
Oh, yep, we're here now.
Hello.
So you were on the
Okay.
red side of the graphic.
Okay, so good. Thank you. You remember.
You're welcome.
Fantastic. I like that my computer tells me that I have an internet problem after I come back. So yeah. All right. So what we got here is, this is the side here that is the sun's energy coming down. We need to get rid of that energy. The Earth will try to get rid of that energy by emitting colors that would be underneath this kind of bluish curve or this black curve, any one of these curves over here. But the energy that actually gets out is only restricted to over here. That's because all of these colors out here are getting absorbed by water. That's this chunk over here. Carbon dioxide is this chunk, and then water vapor is the rest of it. So we say that light's getting absorbed. It's really not getting absorbed. What we mean by it is that we expect to send up this much infrared going up, and if we had a detector, we'd expect to see so much of it. As it's going through there, some of that infrared light is getting redirected, and so not as much gets up out. So that's what we mean by absorbed. So when you see light getting absorbed, it really just means it's getting redirected. And so some of that is getting redirected back down.
You froze again.
It's redirected by greenhouse.
We had you at redirected back down.
Okay. You hear me again?
Yep.
Okay. So that was about it. It just gets redirected back down. I'm going to get out of this slide because that's twice now. So this must be a bad slide. Right. So here again, here's a kind of another little thing here. About 342 watts per square meter of power is coming down. So a watt is a joule per second. So a joule per second is the power required to lift an apple 1 meter in 1 second. So 1 meter is like 3 feet. So if I have 342 watts of power, that's lifting up 342 apples every second. Right, so it gives you kind of an idea. It's kind of a ridiculous thing, but it kind of also makes sense. And then this square meter down here is that every square meter of Earth, that's how much energy, we're getting enough energy to be able to lift up 340 apples per second. So that's a lot of apples. Of that, some of that gets reflected straight off the ground or by clouds or something like that. And about half of it or so is getting absorbed by the surface and warming up the Earth. The Earth puts that back up. It does it in the form of heat. That's our weather. That's our thermals for our birds that are soarers, right? And so we see that about what is coming out is about what is left over after it gets re-emitted. And so that's it. Everything has to balance. And now what we're doing is we're putting more and more CO2 into the atmosphere, and we are readjusting. Our planet is getting warmer. And so we can measure this. And so if you go to climate.gov, there's a great global climate dashboard that you can look at all these things and stuff that we know, right? Average temperature is going up. Sea level rise is going up. Interesting fact about that sea level rise. We tend to think about that sea level rise as being due to the melting of glaciers and so on, and it is. But half of it is due to the ocean itself getting warmer and the water expanding. So I don't know. The amount of heat that we're putting into the ocean is tremendous. So 10 to the 22, that's one with 22 zeros after it. So that is, I always have to think about that. That is 10,000 billion apples of energy, lifting up that many apples in 1 meter. I don't know. Other things we see, glaciers are melting, sea ice is less, spring snow cover is less, which is a big deal. This is the island nation of Tuvalu. This is their climate studies station. It's going to be underwater pretty soon. This was what it looked like during normal high tide. Recently, high tide now comes up to where the buildings are. And things, pictures that we've seen, I'm sure, before glaciers are going. The drunken forests of Siberia. This is the tundra starts to melt a little bit, so the trees start to tilt, but then they want to find the sun, so they tilt this way, and then the tundra melts again. Now they got to tilt this way, so it's kind of weird. All right, so how do we actually know all of this stuff, like that we are causing it? So this is a picture that I like to take from this is from the IPCC. This is looking at anomalies going back to 1880. The black line is the observed data, right? So this is the difference from the average here was taken between 1960 and 1990. The red line, the black line is what we're trying to match with our models. So the first thing that we try to do is we use, if physicists know anything, we understand, one thing that we understand is the Earth going around the sun. We've got that thing nailed, right? We've got that. And we know that there's these little wobbles that happen. And, you know, part of it is the shape of our orbit changes a little bit and our planet wobbles a little bit and things like that. And so we know how that's going to affect how much sunlight we get. So we can actually see this sort of thing. And this is actually, this is actually the sunspot data, or the sun gets brighter and dimmer and so on. And we see that that's great. There's a bit of an increase over here, but right about now we should be in a lower temperature due to that. That's not what we're seeing. We can add things in like volcanoes, but you know, that tends just to make things dimmer and make things go down. And so we don't really see that. We actually understand things like the El Nino Southern Oscillation and stuff like that. So we know some internal variability and we can get that. And none of these things match this black data, which is the line. And then we come to the human component. And we know how much light is scattered by CO2. And we know how much CO2 we put into the atmosphere. And the only way that we can actually get a recreation of the global climate data is by including that anthropogenetic component. We're doing an experiment on the Earth that we ought to be able to do. But one of the nice things about doing computer modeling is that we can do the experiments that we want, and we can turn off these various things. And when we turn off the human part of the picture, we get okay agreement down over here, but we certainly don't get any of this agreement. We know that this is what is happening. And it's not just one computer model. We have, 20, 30 of them all running. They all make different assumptions. And so they don't all agree with one another, but they all follow this same thing. So between the fact that we can recreate historical trends and that all of these different models that are doing things in slightly different ways all agree with one another, and we understand the basic physics behind all these things, it's like we have all of these lines of evidence. Right? If this wasn't climate change, if this wasn't human-caused climate change, then we are living the world's worst detective novel, right? Where everything is so clearly, obviously sending, this is the person that did it, and then also you're like, yeah, no, it's not. It was this bear or something like that, right? It'd be the most, it's inconceivable that it would be anything different. So, where are we? What are our options? If we start getting into larger amounts of CO2, we can move that over here and we can see what that happens with risks. So why this 2-degree mark that relative to pre-industrial levels that is in the news so much? What that means is that this is color coded for additional risk due to climate change. And if we stay at 1 or 1.5 degrees, we see that the risk over here is bit for unique and threatened systems, but in terms of other bits, it's not as risky, which means that we have a better chance of adapting to the world that we wind up being in. Once we get up above 2 degrees, the world's not going to melt, but it becomes harder and harder to adapt, right? And so that's the key thing. That's why we're trying. It's not like 2 degrees is this magic number. We don't even really know if
Yep, we're waiting for your video to catch up. It's not like we really know.
I know. Oh, here we go. I'm back, right?
Yes.
Am I back? Yeah, see, because it told me. Okay, so what I was saying is about this 2-degree mark right over here, right? If we go above that, like I said, what this is meaning is that it becomes harder and harder to adapt. It doesn't mean that it's impossible. It just means that it's going to be harder. And it's going to require more efforts to adapt, right? So if we stay at 1.5 degrees, our options, our ability to adapt is much higher. That's really all this magic number of 2 degrees really means. We don't want to go above it, but it's not like it's going to be the complete catastrophe, apocalypse that people tend to like to say, right? And this thing about that we need to get to a certain point by 2030, what that means is that if we don't get to this point by 2030, we're going to have a harder time to stay below that without having to use significant technological things like carbon sequestration and stuff like that. So we really want to get that number down, as our emissions down as fast as we can, so that we don't have to like rely on more and more esoteric things to be able to help get us back down there. That's what that's saying. Now, the good news, there is some good news. And I really, really want to stress this enough. When I started teaching this sort of thing back in 2012, 2013, the worst case scenario, which was kind of the business as usual model, would put us up at 5 degrees Celsius. Okay. We want to get down over here. This is our fossil fuel emission. This is where we are historically. This is where we need to go in order to be able to meet the Paris goals. This yellow is our pledged policies. And this orange line, though, is our current policies. And so what happens is that we've gone in the last 10 years from our worst case business as usual policy being way up here at 5 degrees Celsius to probably, we've actually done enough in the last 10 years to significantly change our trajectory. Our probably new worst case scenario is somewhere between 3 and 4 degrees Celsius. Not a place that we want to be, but a far cry from this. If we were getting this, this was going to be really, really bad. To get to 4 degrees, we would have to actually do a lot of reversals of what we've already done. And so given our current policies, we're in striking distance. So it means I look at this as two things. We're not where we need to go. Our pledge policies for the Paris Accords and stuff like that are nowhere near getting us to where we need to be for 2 degrees. That's bad. On the other hand, our kind of like wandering around in the dark, not really thinking things through policy is actually already changed, made significant change. We've already put ourselves onto a different path. Not a fantastic path, but a heck of a lot better path than we were. So that means that we can do it. It means also probably means that the easy stuff's already been done, right? If you can kind of bumble around and get that well, you've probably got all the low-hanging fruit. But we've made this change. We can continue to make this change. So we are making progress, right? We are not emitting as much as we are, but we are still increasing our global greenhouse gas emissions. And I still have to see what the overall is after the pandemic. I know that there's been signs that it's been going down, but it's not clear yet. I don't know if the numbers are fully out yet. It usually takes about 6 months after the past year. We're not where we want to be, but we're not where we could be either, which is a good thing. So this brings me to the kind of the what to do about this. See, I'm running a little bit late. I knew it. And I tried to speed up. The usual picture, and the picture that we still have, is by looking at it by country, right? And so we can look at fossil fuel emissions and projections. And so, you know, the United States is the big culprit, and we're coming down, but not nearly as well as we should. Then China, with its industrialization, is going on. And what I would argue, too, is also that we're going down over here because we're moving a lot of our industry over here. So
We'll pause for a second. Let us know when you're back, Kevin.
am I back?
Oh, yep, I think you're back.
Yeah, there we go.
Okay, so we got that.
So it's not love in the time of cholera, it's Zoom in the time of pandemic. But,
Yes. So we were
yeah,
at the
look at that.
reduction in the US line because the
Oh yeah,
it's shifted to China as opposed to really eliminating it.
Yeah, so we like to, you know, pretend that we're doing really well and then blame other people. But So that's kind of that's one picture, and that's certainly the picture that is kind of under the Paris Agreement talks and stuff like that. Oops, that's kind of out of place. But I do like this. We'll take a little break here to take a pause here and use this phrase that I came across in a Seder. It's your responsibility to complete the work. It's not your responsibility to complete the work, but neither are you free to desist from it, right? It's not on our shoulders to fix the world, but we've got to do our bit. So what should we do? So, this is the typical thing on, eat less meat, swap your car or plane for a bus or a train, and blah, blah, blah. And when you last saw me 2 years ago, I talked about things like that, right? And it's great. That's fantastic. We need to do these things. We need to make changes. But individual actions are only important collectively. It is too big of a problem to put on an individual, right? Not only that, but not everybody can participate. My economic background allowed me to be able to front some money to put solar panels on my house. Not everybody can do that. If you're a renter, you can't do that, right? If you are living in a condo or something like that, you might not be able to do that. You might not have access to be able to swap a car for a bus or a train. You might not be able to be in a place where that will work for you, right? And so we need to, part of working collectively is not just individual actions being multiplied by telling people to do this and getting them to follow what we're doing and stuff like that. We need to work towards a world where everyone can participate in this. So just as an idea, though, just because it is the individual changes are important. So if we think about reducing our emissions by 20%, that's like turning off your electricity for 1 year. If we can get everybody that is, almost everybody that's in this, I think there's a few doubles in the participant numbers I'm seeing here, about roughly to do this, it's the same as not burning 6,500 gallons of gasoline or keeping 130,000 pounds of CO2 in the atmosphere. Again, a drop in the bucket. 130,000 pounds sounds like a lot, but it's nothing compared to what we're putting into the atmosphere. Oh, I see a question. Carbon tons of CO2 per capita in the United States in the 1970s was high, but then came down. Yeah. So yeah, thank you. So let me go back to that real quick. So it came down over here. That's because that's when our economy collapsed in the 1980s, right? So everything was going, and we had these big cars and everything else, and it was going up, and then all of a sudden we had stagflation, sorry, where we had the great thing of the inflation and a stagnating economy at the same time. And so that caused an increase in, and also that was the oil crisis, the aftermath of the oil crisis that happened in the mid 70s. And so there was a push towards smaller cars. And then all of a sudden, when gas was not quite of a big deal anymore, we started buying bigger cars. Then that goes through the 2000s. And then after this is starting to be right around the time where the economy collapsed again. So usually when the United States CO2 emissions go down, it's usually when the economy is collapsing. And then we just kind of stayed over there, and that kind of coincided at the same time with falling prices in solar energy and wind and things like that. So yeah, and also around this time, like I said, we were pushing more and more of our industry to places like China. So I will.
Quick question,
that to me.
Kevin.
Yes.
Question is, do you know of any examples of communities that have collective programs that support participation by more people for carbon reduction?
Ah, that is a fantastic question. One of the things that that's coming to mind right now, actually locally, is, and it's brand new, so it's still something that it's not clear exactly how well it's going to. Actually, I have a couple of them. So one, the one I was going to is Ithaca. The town and city of Ithaca has just put forward a new green building code which far surpasses anything that New York has, either in that or in the New York State stretch code. So that's a big thing. And that's also going towards remodeling and stuff like that. At the same time, if I remember correctly, Ithaca is moving towards like a Green New Deal kind of model. And I still have to look into that. I just came out in the last week or two, right when my semesters were changing. So I haven't been able to focus as much on that. But another thing that's very, very important here. So you were talking before this about the presentation that Bennett Sandler is going to give. Fantastic presentations. If you can go see Bennett give a talk on this sort of stuff, please go do so. It's just fantastic stuff that he has to show about what he's been able to accomplish and what's now available for the Otsego County and the surrounding areas. So one thing, though, is going back to that regional greenhouse gas initiative that I was telling you about, that kind of collective bit with people here on in the Northeast. So what happens there is that the way that we're getting our greenhouse emissions down is through a cap and trade program where the states put out sort of pollution cards, if you will. You can pollute this much, and as a way to help mitigate. So they lower how much you've got to get, and then they'll give you a little bit to help you get down there. But then the expectation is that you'll start to if you're a electric power company, you start to find ways of doing things better. The selling of those permits is partially what allows you to get things like Heat Smart Otsego. It's what allows you to get like rebates, and low interest loans for like solar panels and things like that. So a lot of times it goes into, some states have it so that some of that money from the permit shares go to what's called green banks, which are banks that work together with private and public capital to help small business and homeowners make changes to their business or their home to make things more energy efficient. One of the things, if you're a small business owner or something, that you probably already know this, it's very difficult for small business owners to be able to get enough capital from business loans to be able to do a lot of this stuff. It's hard to get loans to begin with because they're not making enough money to take on that, to mitigate the risk that the bank feels that they're taking. So these green banks that are funded now through things like the selling of these pollution permits, one drives the pollution permits down, pollution down, but at the same time is causing funding to open up these sorts of things. But this is something that really needs to be worked on. And this is something that places like the DOAS and other places like this can really, really make a difference, putting their mind to it and working with other groups nationally or locally to put pressure on people to get this funding available, either through laws or through taxes and things like that. So yeah, it's really, we're starting to get into the mode where we're thinking about how to do things like that. So if we were able, so fantastic question. So if we're getting back to about 100,000 people, which is about a little bit more than what Albany or Otsego County as a whole, I think both of them are around the 60, 70,000 mark, but it's about the idea. If we were able to get like Otsego County and Albany to reduce their emissions by 20%, that would be the equivalent of replacing Las Vegas with a forest. Admittedly, a few mixed feelings about Las Vegas. It's kind of cool that it exists. On the other hand, it's also kind of really bad. It exists in the desert, but anyway, it's again, 20% emission reduction is not a huge thing. And if we can collectively get everybody to do that, we can make big changes. One of the reasons that we are making these changes, one of the things that has gotten us onto this lower level are things like simple things, like if each house in Albany replaced their incandescent bulbs with LED bulbs, it would be the equivalent of turning off the electricity of 6,000 homes, right? So the small individual things matter. Getting it done collectively is the way where you start to make a big deal. My favorite one here is if you were to take every home in Albany and make sure that it was well sealed, it would be the same as keeping not burning 1.6 million gallons of gasoline every year. One of the reasons why I really like this, and this comes back to this, making sure everybody's on board, because not only are you, if you're keeping your house well sealed, are you saving are you saving the earth with not having CO2 gases, but you are directly helping the people that live there, right? A vast number of people in this country, even before COVID, in the wintertime, were experiencing what was called energy poverty. Something like a third of all households had to make a choice between paying their energy bill or food. Right? And part of that is that if you have a leaky, not well-maintained home, you're burning so much energy just to get rid of that draft, right? And so again, this is one of those things, is that we have to make these things accessible, right? We need to put pressure on and make it so that landlords are responsible for maintaining buildings and making them, that there's no incentive for them to do so, right? The cost to make the homes more energy efficient are costs that are borne by the landlord, but the benefit is to the people that are leasing, that are paying the electric bills, right? So these are the sorts of things that you kind of got to keep in mind when you're doing that. So if everyone in the United States reduced their emissions by 20%, that'd be like taking out 1/3 of the country's coal plants. If we increased our home efficiencies by 10%, that would be removing 25 million cars from the road or the equivalent. Right? So this is big. We need to make these things, but rather than think about them as, oh, I've failed as a person because I didn't recycle today or something like that. The problem is we live in a world where it's very, very difficult to make changes. I tell my students that I want to compost. So if I were actually to have lunch at my school, I would be able to take my leftovers from my lunch, bring it back with me, and compost it in my backyard, or find somebody that would do it for me, right? Up at the school, there is no composting. So if a student wanted to compost, the infrastructure that they live in prevents them from being able to do the right thing. So one thing that I'm trying to get away with, we know what we need to do, but what we need to do is we need to get away from thinking and cajoling people to do the right thing, but making it possible for them to do this. So we'll skip that. Because the real truth of the matter is that 70% of all industrial greenhouse gases since 1988 are due to 100 fossil fuel producers. Fossil fuel companies and their products have released more emissions in the last 28 years than the 237 years prior to 1988. Half of the global industrial emissions since 1988 can be traced to just 25 corporate and state producers. Half of our greenhouse gases that are in the air now, emitted since the start of the Industrial Revolution, have been from these 100 fossil fuel producers. And the bigger thing to realize is that these ideas are out of the reach for most people. We need to make that change. For instance, this is the line that we're currently on for CO2 and methane and temperature changes and sea level changes from average. Let's skip over here. If we didn't have those big producers over the last 30 years, we would be down here. We would not be pushing 400 parts per million in 2010. We'd be down at 330 parts per million. Our temperature would be different. This is a direct cause of 100 companies. Right? That's where we need to focus. So we need to put a price on carbon emissions. I saw recently that President Biden's administration is at least doing that. They're going to put a higher price on carbon emissions than we have. We need to stop subsidizing fossil fuels. We spend $20 billion a year in the United States to make fossil fuels artificially cheap, and globally $5.2 trillion. Imagine what that money would go towards renewables. Right now, renewables don't get anywhere near that subsidy, and yet they cost less now to build out than a coal or a fossil fuel plant. We need to stop building new coal and natural gas plants. We are seeing building that are still being built out. We need to electrify more than we can. While we cannot innovate our way out, we need to pour money into innovation to help. We need to get rid of the internal combustion engines in our cars. We need to fight for zero deforestation supply chains. We need to implement policies for regenerative agriculture. Unfortunately, our newest ag secretary that just got what do they call it? Got approved by Senate today is not going to do that, right? And so these are the things that places like the DOAS or a church or a group, a consortium of people can do, is to put pressure on your communities to work through this, right? To implement policies. So try, get people to do this sort of thing. If you have another group that you belong to and you think that this is worth your time, I will do this again. Just let me know. In the chat, you should have a link to this very web presentation so that you can use it to talk to others. You can take whatever you want from this and reuse it. This little picture down here means that I give you the right to do that. Right? Sometimes the hardest thing to do is to get started. You need to vote for candidates that are actually willing to be bold on climate. You need to work with your city or your town or your school district or your workplace to do these sorts of things and to put pressure on government. Praise the politicians when they do good things, smack them on the wrists when they don't. Write letter campaigns and make sure that you put in your letter campaigns to a newspaper, you put your congressperson's name in them, because they have interns that scour the newspapers looking for their names. And if they see their names starting to get put in on something that they rather not have their names on, they might start paying attention to it a little bit more. Right? We all know how to do this. Keep calling. The biggest of all, run for office or participate in local government. One of the best things I've ever done personally is to be a part of the Oneonta Environmental Board. My life has changed for the better because of it. New prospects have opened up. I'm teaching new things. I'm doing all sorts of wonderful things. I'm connecting with people in this community and other communities, and we can start to band together and actually start to see stuff. And it's very exciting because you look over there and you're like, oh, that city's actually already doing that, and that city's doing that. And so that means that we can do it. And I can ask them how they did it. And so that's that. Make the ethical choice that you can when you can. If you're not able to do something because of finances or whatever, don't beat yourself up over it. Instead, work with people to fight to make it easier for us to do the right thing. It is very difficult right now to live the life that we ought to be living because the infrastructure around us hems us in. So we want to try to make the world be the way that we want to live in it. And so I will end there. So I will be happy to take any questions.
Yes, Kevin, I do have a question.
Yes.
The question is, could you address the role of our factory farming practices, particularly for the meat industry in climate change? I've been told it plays a bigger role than cars.
It's up there. I don't remember the exact numbers, but yes, the meat industry and modern agricultural industries contribute a great deal to climate change. Meat is a very water-intensive product, if you will. It also modern ranching and modern meat production involves very environmentally detrimental things. Most of the meat that we have, certainly in this country, is corn-fed, right? So that means that we have to have more and more land devoted to corn, which means that we are more and more of a monoculture, which is terribly bad for our soil. And not only is it bad for our soil, but because of that, it takes out all the nutrients and compactifies the ground. So then we have to put more inputs into it. That means we have to put more fertilizer, we have to do more stuff like that, which has a trickle down effect, if you will, on the climate. A large part of why rainforests are getting cleared out is because of an increase in factory meat production and making more room for corn. So now that being said, so full disclosure, I'm a vegetarian. I'm a vegetarian for a number of reasons, but there is a lot of arguments that would say that if we really, really wanted to have a healthy agricultural society, it turns out the healthier the soil is, that the soil can actually be much more able to pull out CO2 from the atmosphere. So having healthy soils is also a direct thing for combating climate change. And so part of having healthy agriculture is actually having animals as being part of that. Certainly not factory farm kinds of situations, but having animals grazing alongside your crops and things like that. There's a lot of fantastic research that's been done with that. Susan, somebody had asked me about that, or she had directed me an email about that, and I sent her some book links. So maybe, Susan, if you could put that up in something on the from that email from last week,
Yes.
Or I can find some space to put that up in the network as well. But yeah, so it's a big thing. But it's, again, regenerative agriculture is kind of looking at it saying, well, how does nature work? Nature works between the interaction of animals and plants, right? And so a vibrant forest, a vibrant area like that is due to that interaction. And so perhaps we should try to model that in our farms.
Kevin?
Yes.
Could you return to the electrify everything idea?
Yes.
And talk about, if you electrify things that we still need to spend energy to make the electricity. Is there actually a good trade-off there? For example, if I went with an electric car instead of a gas car, still the electricity has to come from somewhere. So
right.
What is the trade-off?
So the trade-off here is that by and large, so for instance, in New York, most of our electricity is coming from nuclear power and from natural gas. We no longer, for the last 5 years, burn coal. So at that point, because of our energy mix and then the growing renewables, it's the savings, the carbon savings is substantial. Much, much larger. Even if you're getting it from natural gas, using natural gas to get to electricity and is still burning cleaner than gasoline. Right. So as long as you're not, pretty much from what I can tell, as long as the state that you're in, that you're getting their electricity from, is not getting it primarily from coal, you're better off. Right. And the more that we go towards solar and wind and things like that, the less the cleaner it is. There's other issues, obviously. So building the car is about the same amount of carbon emissions in building either an internal combustion engine or an electric car. My issue with electric cars and things like that is batteries. The metals, the mining of the metals is not really healthy for the miners or people like that. And so the other thing, and I haven't gotten into this, I haven't really figured out how to get this into my already overlong talk, but this time it's only 10 minutes. So I'm doing better.
Well, I do appreciate that. I know just like there was a January article in the New York Times that talked about emissions change from work at home restrictions. Emissions fell by like 10% just from that change in our habits. But my issue, like a car investment for me is, like a good 10-year investment. So when I make that decision, which I'm in the process right now of researching options, I can't do, like the state has great incentives for new vehicles. but those vehicles are $30,000-$40,000 on the low end of the spectrum, and there's no incentive on used cars. Like, I can find reasonably priced electric vehicles that are 2 years old, maybe 3 years old at the max. But even if we had the option for new cars on the lower end, which Volkswagen makes one in Europe that has taken over Tesla sales, but they won't release that model in the US because it's not an SUV and Americans don't want to buy small economy cars. But the rebates, I mean, if I don't make enough money to qualify and really benefit from a tax rebate, where's the real incentive? It's very frustrating for me to think about this. And
So
the
this
same
is-
thing with home retrofits. Like, my goal is to get off of fossil fuels because I pay a hell of a lot of money, in fuel oil every month. I have an 1900 farmhouse that
Oh,
I'd
and you're
love
doing
to
oil?
retrofit.
Oh, I'm sorry. Yeah.
So sorry for my rant, but
No. But this is my point, though. Okay, this is exactly my point. Most of us who are lucky enough to have the mental space, the time, right, that we're not being crushed by everything else to actually think about these things. A lot of us, we know what we want to do, but there are these barriers that are in our way. And so, to me, what I'm going to tell you is that, honestly, if I were in your situation, which is what I was like 5 years ago when somebody crashed into my parked car here on the street, I had to get one, is I bought the best used car I could get because that was what I could afford. And rather than buy a new car that was a combustion engine, I decided to go with a used car because there was already some sunk cost into that, and go with that. And so that's the tension that I'm talking about. So on a personal level, do the best you can with the resources that you have.
right.
And then fight like hell to make it so that everything else, so that you can make that decision, so that you can make it, so a friend can make it, so other people can make it. We shouldn't have to be in a situation where it's so hard to do the right thing.
No. Well, I've been looking into some of those collective programs, like, I'm researching other communities and what other places are doing to help bring these kinds of things within the reach of, mainstream, communities. I think we definitely have challenges because we're in rural, sparsely populated regions, which makes a lot of those types of concepts more difficult for us. But it shouldn't be impossible. So if anybody, that's one of the reasons why, I want to continue these conversations in the network, because people can bring some of these ideas, or if people happen upon a resource, I'd love to see, what we could do and what we might be able to push. And I love that you mentioned things like letter campaigns and, op-eds, write a letter to the editor and put something out there and reference your elected officials and get their attention and start working within our communities. And that's one of the goals of this whole climate action project. And it could be something as simple as writing a letter to government officials and maybe making appointments or meeting with people. But it can also be the start of something more than that, that might take some funding that, we hopefully can use some of our grant money for this program to get some local initiatives off the ground. So before
Absolutely.
we end, I do want to just show people the carbon tracker, and I promise I won't take any more than like a minute to do this.
Yeah, I've said the same thing.
I'm going to share my screen. I know. I'll try to promise it won't take more than a minute. So you should be able to see my screen now.
Yep.
Is that correct? So basically,
Yes.
the little C button at the top will bring you to our carbon tracker page. And when you click through to this, and there's some information about there about this, and it talks about like some of the confidentiality issues. Like your data that you submit is still private, but as an admin for Delaware-Otsego Audubon, anybody who goes through and does this through our website, we'll be able to have aggregate data on that. So we'll be able to look at carbon emissions throughout our region from the people who have entered. And then as you go along, you can change your answers and we can see the difference over time. So I've already done this, and I'll just show you the carbon tracker, what comes out at the other end of it. So, you know, my carbon, you go through questions about your transportation, your heating, your electricity, your food and waste practices, goods and services, zip code, overhead. And you just be as honest as you can. You reference your invoices from your electric bill or your heating bill to figure out, you know, how many gallons of fuel oil or, you know, what your source is that you burn. And it'll give you estimates on how much carbon you're using or you're emitting currently from your household. So you can see my carbon results right now are huge, you know, 53.6, you know, I have a household with 4 people there. The blue line represents average zip code. So the average emissions from the average household in my zip code are less than my carbon emissions in my household. And then where you can, you know, work to bring some things down. Transportation for me is on the lower end, but that's because we're a 1 vehicle household and we use our car minimally, especially now with COVID, with, you know, a lot of people working from home. So we have 1 commuter and, you know, a lot less running around. But heating, you can see I'm well over the top. We have fuel oil furnaces and, you know, it's huge. And I would love to be bringing that down to 0. I just need to find a way to do it affordably. Electricity, I'm less than our average zip code average. Our food and waste is more because we do, you know, we are red meat eating families, but we are shifting to, you know, meatless Mondays, or, you know, basically trying to go at least 1 or 2 days a week where we pare down on consumption. And when I change that number in the questionnaire area, that's going to reduce what I see in my graph. So eventually over time, I want to see this come down as low as possible, which obviously it'll never be nothing, but I can use offsets and things like that to bring it to 0 over the next 20 years. So it's a really nice tool, and there's helpful links and information and fun, you know, like what financing resources are available in New York State. I mean, those links are in there. You know, it's a nice tool to have. So I really want to encourage people to use it. We're going to be sending out some media releases this month on that. So hopefully we'll hit the newspapers and kind of promote throughout our chapter region. So we want to make this for anybody to use and start looking at climate and carbon as something to move forward with. So anything else anybody would like to add? We're looking at any questions and answers. I think we're done with questions. Your presentation was very scientific, Kevin. So, you know, like I kind of looked and said, okay, I'm really glad there's graphs in there so that I can kind of keep up a little bit.
I hope to try to keep it, I hope to try to make it understandable, but I want to go back to that carbon tracker though. Again, I want to caution everyone when you're looking into that if you are, like you, Susan, above, which is going to happen, I really don't want it to, people should not be looking at this as some sort of personal failure or getting, use it instead as a way of what can I do, and look for those places where you're getting jammed up against that, where you're just like, I cannot find a way past this. And when you do that, you'll find that log jam that's happening kind of within our kind of infrastructure in which we live. And those are the places where you start to think, maybe that's where I start to organize some action around, right? Because I see no way past this right now. We need help to do that. How are we going to do that? And so rather than look at it as, where do I change personally? I mean, it does that too, but then you can look at that and say, oh, especially as a community, as people are using that, you can share this stuff and say, where did you get stuck?
Exactly.
And then that can help.
And that's some of the result that I'd like to see in that network program, the online network where we can share things that we find. And if we have success or if we have roadblocks, that we can discuss those in that forum as kind of a safe place to share information and support each other and kind of get a real community working together collectively, etc. So good. Well, thank you very, very much. We definitely appreciate everybody's time this evening and your time and expertise, Kevin. And I will, we do have a recording available for tonight. I will process that through sometime over the next couple of days and have it online at our website, so that if you want to share it or rewatch any part of it or link it out to, through social networks or anything, you can certainly feel free to do that. And I'll include those resources as well, those resource links and the book list that you had sent me. I have to find that email. So
I can post those again too. So
great.
Well, thank you again for having me. Again, happy birthday, Mom. Thanks, Diane, for coming. Thanks, mother-in-law, Judy, for the mittens. And there we go. So everybody else, thank you again. I really appreciate this opportunity.
Great. Thanks again. And good night, everybody. We'll see you
All right.
hopefully next week at the March 3rd ins and outs of electric vehicles. I'll get to rant some more.
There you go. All right. Good luck. Good night, everybody.
Good night.